Do you hear Riley? He's saying, hey Ebersole, you see that desk you're sitting on? This is what I hear from him. See that desk you're sitting on? That's where I want to sit for the rest of the year. Because when I sit way back here, I talk too much. I'm just foreshadowing for the next hour or so. All right, for real.
Cool.
Reflexive property. Get him, Ethan. I'm sorry, I didn't mean to rush you. You were helping me out. Reflexive property. Somebody tell me.
Anything equals itself.
That's it. Theorem. What's a theorem?
Something
Go ahead, Cameron.
Rule that has to be proven true.
Math rule that has to be proven. Postulate.
Something that we take for granted is true.
Something we take for granted is true. Should know all three of those. We're going to continue to do these throughout the rest of the year. So make sure you. Mason, just because we did them today, does that mean it's not going to be on the next one? If I'm doing them up here, it's probably stuff that you should know all the time, right? Every time you walk through that door.
What's the theorem?
What's the theorem again? Help Branson out.
Something that has to be proven true.
Math rule that has to be proven true.
So can I say a statement that must be proven true?
Yeah, I'd probably go for that.
Wasn't it a rule or statement? Well, we said.
Let's go.
Questions on page 309.
Nah. I say we just get our notes done and be done.
That's a fair point. I feel like we could do that.
I feel like we could just get our homework done in class and we do the notes fast.
Can you do,
I'll check, but I'll for sure.
what's number 18?
You said something smart.
It's a problem after 17.
I mean, like,
What's the answer?
yeah.
All right.
All it says is there enough information?
So they give us this picture. You got to start knowing this stuff yourself. You got to start being able to do these 2-column proofs. Guaranteed when we take the next test, it's not going to be easy because most of you just think, oh, I'll just skip over these proofs, I don't like them. They give you that information. What's the 2 ways to prove it good? What's the 2 ways to prove a triangle or 2 triangles are congruent? Or
Side angle side.
in this one, what they give us so far?
2 lines that are
2 what?
segments.
2 segments. Lines can't be congruent. Some of you are writing that down. I think on midpoint, when we did midpoint on one of the quizzes, the other time, some of you are putting down point that splits a line into 2 congruent parts. So if I draw this line, this has nothing to do with this problem. I draw this line, I tell you to come up and split it into 2 equal parts. Is that ever going to work? Why not? It's infinite. Keeps going. Lines can't be split into 2 equal parts. What can be split into 2 equal parts? Segments. What else can be? Segments. Angles. Those are the only 2 things that can be bisected or split equally. All right. So we know a pair of sides right now.
That's all you can know, right?
Is that all we know?
No, because it's transversal. No, because they're not parallel.
So we don't actually have a. It's sort of a transversal, but what Jacob's trying to say is, what do we know about that segment? It's equal to itself, so we could mark it. So that's another pair of sides. Is that enough to say that the 2 are congruent?
No.
So do we have enough information to say that these 2 triangles are congruent?
No.
No.
Okay.
What if they would have told us that this segment was parallel to that segment?
Then we could have used the alternate interior.
Then we could have used those alternate interior angles. Then would we have had enough information?
Yes.
Yeah, by side, angle, side. All right, but they didn't tell us that, so the answer is no to that. Other questions?
Together. We're good. We'd like to do the notes. Apparently. Jeez.
Grab the notes up there, fill in what you need to fill in on this. We're going to learn 2 more ways to prove that 2 triangles are congruent. So now instead of 2 ways, you're going to have what?
3.
4 ways.
Go back a couple years, Cameron.
So does mine. Mine says USA.
Where's the A? Where's that SSA?
What do you think ASA stands for? Angle, side, angle. So a pair of angles.
It's NASA without the N.
Not gonna put up with any more crap today. Pair of sides, so if you wanna say something silly, say it, take the detention. Pair of angles, pair of sides, pair of angles. And when we talk about it, you're gonna see that that pair of sides has to be a special pair of sides, just like for side angle side, the pair of angles had to be special. Alright? Now, the reason these two are a little more confusing than the other two is because it's real easy to get these two confused. What's this one say? Pair of angles, and then a pair of sides. So you got to be real careful when you're going down through and you're doing your 2-column proof. You got your statements, you got your reasons. We get down here to whatever number, however many it takes. And we get to number 5 and it says some triangles congruent to some other triangle. And we know our reason has to be either one of these two or one of the two that we learned last time. That's the only reason that can go there when you make a statement that 2 triangles are congruent. Nothing else. So if you put anything else there, it's wrong. And I'm telling you right now that nothing else could go there. So if I don't know anything about this 2-column proof, tell me something I could write right here as this reason.
Angle side,
Angle, side, angle. It's got to be one of those abbreviations.
I'm confused.
That's the only thing that can go in there. Somebody help Branson out because he said he's confused already, and I really can't understand how.
Are
Well,
you,
this example, it says triangle KLM is congruent to triangle ALM.
Right.
You said only triangle has to be ASA.
Right, so this triangle congruent to that triangle. I just didn't write out the names of the triangles.
And how is this one SSA?
Because what's the other thing? So we said angle, side, angle. What else could it be?
AS?
Angle, angle, side. What else? Side, side, side. What else? It's got to be one of those
Oh.
4. When my back's turned and Elizabeth, you want to talk and because you think Ebersole can't hear me, instead of talking, throw something at Branson because he's not listening apparently. Come on, Branson, I said any of the 4, man. They just happened to pick angle, side, angle. I don't know why they picked it. Luke, I was joking, don't throw stuff.
a little bit.
Fill in what you need to fill in on this. So ASA, pair of angles, pair of sides, pair of angles. The angles, the sides have to be the included pair of sides. In other words, whichever 2 angles you're dealing with in each triangle, the side has to be between those 2 angles. So if I draw this picture, this is our triangle, NTH over here. And I mark that angle, and I mark this angle. Which side is the included side in that triangle?
NH?
Does everybody see that? It's got to be the side that is surrounded by the 2 angles that you're dealing with. That's the included side. So if it was this side over here, is that going to fit angle, side, angle?
No.
No. But the next one that we're gonna go over is angle, angle, side. Angle, angle, side. So that one would fit this. So unlike the other time we said when you had side, angle, side, so if I knew this side was, and that side, which angle is the included angle for those two sides? H. So if I knew that, then I could use side, angle, side. If I know this angle, did it work? Alright? So this one and the other one that we're going to cover today, a little confusing because they both work, but you got to make sure you look at your picture and know which order you're going in. Alright? So if I go back, let's get rid of this. If I go back and I put in this, are we using angle, side, angle, or angle, angle, side for this information here? Angle, angle, side. See how the side's not between the two angles?
Yeah.
So then we have to use angle, angle, side. What if I had this information? Angle, side, angle, because the side's in between the two angles. So you gotta know, you gotta be able to look at it when you get done with everything, mark in your picture, and you get down to the very bottom, know which of these theorems you're using. First, let me go through this real quick, then I'll answer your question, Kelly. What do I know about those two angles? They're congruent. This is what kind of angle? Right angle. This is a right angle. What do you know about two right angles?
They're always congruent.
We had a theorem that said all right angles are congruent. So anytime you see this somewhere in your two-column proof, you're going to have to put in there that those two angles are congruent because all right angles are always congruent. So right now I have a pair of angles, another pair of angles.
What are we trying to
And
find?
side.
We're trying to prove that the two triangles are congruent. I have a side. What do I know about these two sides? They're both 5 centimeters, so they're both congruent. Now, does this fit? Is that S going to go in between those two, or is the S going to go out here on the end?
In between.
In between. Does everybody see how it's in between the two?
Yeah.
All right, and I'm not sure why I'm using my black pen when I should be using my other pen. So this time we're using angle, side, angle. Let me mark that real quick so it's on the video. So we got a pair of angles, a pair of sides, and another pair of angles. So those two triangles are congruent.
Okay.
Somebody name the name the triangle on the left for me. Say it again.
Triangle GTO.
GTR. All right, I just couldn't hear. Be careful.
And then all the
G matches up to what in the other triangle?
R.
Does everybody see that?
Yeah.
Got one mark, one mark. How about the T? What's it match up to in the other one? E. And what's the R in this triangle match up to? G in the other. Make sure you can match them up correctly. Find this on your notes. Number 1 up here.
They're congruent.
Are these two triangles congruent?
Yeah.
By what?
Feature.
So you're saying yes?
Yeah.
By what?
They're not.
They're not?
No, because the angle is the angle is in between the two sides.
So to be side, angle, side, what has to be true about the angle?
It has to be in between.
So which angle would it be here? Top, left, right, what?
Top left.
It'd have to be that angle, wouldn't it?
Oh.
So is this gonna work?
No.
So are these two triangles congruent?
No.
No. We can't say that they are. There's not enough information. Before we even deal with the triangles on this one, anybody see anything in this picture that you can pick out that you know without them telling it to you?
Vertical angles.
Vertical angles. Does everybody see that?
Yeah.
If you can't pick out vertical angles in a picture, we're gonna have major problems, because that's one of the things you gotta come up with on your own. These two angles right here, vertical angles. So on your paper there, mark them as congruent. Are those two triangles congruent?
Yeah.
By what? Angle, side, angle. So yes, angle, side, angle.
Wait.
So everybody see how the side is between the two angles?
Yeah,
That's the way it's gotta be to be angle, side, angle.
okay.
And this side is between those two angles. Next one. Another thing that you gotta be able to pick out on your own very, very quickly. We talked about this last time. If I give you these two triangles, what's the first thing you should realize before you even start looking at the given information or anything?
The middle is the same.
They share that side, right? Every time you see a picture like this, they share that side. What's that called again? What? Reflexive property, which is what? Anything equals itself. You got to realize that. What if I gave you this picture? What's the first thing you should think about? Anything equals itself. That middle segment there, right? So on, so on, so on. So what do I know about this segment in these two triangles? Anything equals itself. It's congruent to itself. Is that enough to say the two triangles are congruent?
Yeah.
Yeah,
By what?
angle, side angle.
Angle, side, angle.
Couldn't it also be
That just
angle side?
Could it be angle, angle, side?
That's what I'm couldn't we look at these two angles, like
No,
the
because they're not.
two left angles, for example?
So, if I had this, and this might help Jacob, we said last time, sometimes it helps to split off the two triangles, right? So we know that this angle is congruent to that angle, that side's congruent to that side, that angle's congruent to that angle. So which one does it fit? Angle, side, angle. Now, it could fit angle, angle, side if we wanted to make our proving it a little longer, and that's what I'm gonna show you on the next slide, and we'll talk about it. So, sometimes it can fit both, but it makes your proof a little longer. So if you were to use angle, angle, side on this one, and we were doing a 2-column proof, your 2-column proof would be like 2 steps longer. Those other steps would have to be in there to get us to that. These two triangles congruent.
Yes.
Now, we haven't covered angle, angle, side yet. We've talked about it, but not completely. It's going to be on the next slide. The reason, this is what I was just telling Jacob, the reason that we know that these two triangles are congruent, even though we haven't talked about angle, angle, side yet, is we had a theorem the other day that was called the two-angle theorem.
If two angles are congruent.
The third one's also.
If two angles in this triangle are congruent to two angles in this triangle, what do we know about this third pair of angles?
It has to be congruent.
They have to be congruent to each other.
Does that mean it's like a right angle?
No, but it does mean that they have to be congruent. All right?
Okay.
Instead of going through in a proof and using that two-angle theorem all the time, what some mathematician did a long time ago said, hey, if we have this picture, the original picture here without these two things in it, if we have that original picture, we know that the two-angle theorem is going to work.
Oh, okay, yeah.
So we don't have to write it.
So we don't have to write it. We'll just make up a new theorem called the angle-angle side theorem, and that'll cover all of those. Because it's going to work every single time because of that third angle theorem. And it wasn't called the two-angle theorem, was it? It was called the third angle theorem, is that right? Or was it
I
called?
have absolutely no idea.
Was it called the two-angle
It's
theorem?
called the two angle theorem.
Some books call it one, some books call it the other, I couldn't remember. Fill in what you need to fill in on this one. And notice down there at the bottom exactly what I was just telling Jacob a second ago. You could use angle side angle if you added an extra step to your proof. make sure that those quizzes that you got back, make sure they get into your binders where they belong. Have I said that already? So on this one, if I labeled this triangle, triangle A, B, C, and I know I'm dealing with this angle and I'm dealing with this angle, which side would have to be the included side to use angle, side angle? Which one is it? Does everybody agree with that? Be AC. Is that between the two angles? All right. So to use angle, side angle, we'd have to know that side. Well, we don't know that side. We know this side down here. But we just got done saying, and again, I wrote third angle theorem up here. Mark this out. Put two angle theorem. Like I said, the old book called it the third angle theorem, and I think this book calls it the two angle theorem, and doesn't matter what you call it, it's just knowing that two angles in one triangle are the same as two angles in the other triangle, then the third pair of angles have to be congruent. So using that, we could say that this angle is always going to be the same as that angle. What kind of angle is this? Thank you. All right, we don't know, do we? Do not say it's a right angle just because it looks like a right angle. Did they tell us it was a right angle?
No.
So don't say that. But using the two angle theorem, we know that this angle has to be congruent to that angle, and we could put that in our proof, and then we could use angle, side angle. So for whatever reason, maybe Mason doesn't like angle, angle, side, it annoys him for whatever reason. Could he make his proof one step longer and use angle, side angle? Yeah. And that matters to nobody except to Mason and to Mr. Ebersole, because I'm the one that has to grade it, and I have to know when you could use either thing. All right? So, as of now, what are our 4 ways to prove two triangles are congruent? Side, side, side. Side, angle, side.
Angle, angle, side.
Angle, angle, side. Angle, side, angle.
There's more.
What's the ways that don't work?
Side, side.
Angle, angle, angle.
Side, side, angle doesn't work.
Angle, angle.
Remember, we talked about that one last time, right? Angle, angle, angle doesn't work. Does anybody know why angle, angle, angle doesn't work?
Because the side might not be the
Angle, side, side.
So, if I tell you, in this triangle, this angle up here, that angle right there is 90 degrees. This angle's 45 degrees. So this angle's 45 degrees. I'm telling you the truth here. If we
Yeah.
were to measure them, that's what they would be.
Okay.
I got this triangle.
Oh, okay.
This angle's 90 degrees. That angle's 45 degrees. That angle's 45 degrees. And I'm telling you the truth, that's if we measured them, that's what they'd be. So I just told you that all 3 angles in this triangle are congruent to all 3 angles in this triangle that I have in my other hand. Are the 2 triangles congruent?
No, they're different sizes.
No, they're different sizes. Anybody remember what that was from what we just did a little while ago? That's a dilation.
Dilation.
They are, instead of being congruent, they are what to each other? Start with an S. Similar.
Oh.
They're similar to each other. So these 2 triangles are similar. They're not congruent. All right? And that's what AAA, that would tell us that the 2 triangles are similar, not congruent to each other.
If they were all 60.
If they were all 60, would that make them congruent?
No.
No, because they can be similar.
So if I tell you that's 60, that's 60, that's 60, could I draw another triangle that looks like this where that angle's 60 and that angle's 60 and that angle's 60?
Yeah.
Are they congruent to each other?
No.
No, they're the same kind of triangle, but they're not
Yes.
the exact same size, so they're similar.
Angles are different.
Similar is a big part of geometry. We're going to get into it here real soon, and you've got to be able to do things that are similar. You learn your lesson the first time.
What about side angle?
That's literally what we have right
Oh, I didn't see
Doesn't
that.
work, right? So we have those four. I don't know, is that something you gotta fill in on there?
Yeah.
Is it?
Yeah.
At the bottom.
Oh, wait, you on the last page? Yeah, I already filled that.
You were just ahead of us, Mason. I got it right out the detention,
now.
no,
That was funny.
no, it wasn't.
I thought it was funny.
I think Caitlin's laughing because she thinks I'm
Caitlin
gonna write
thinks
you.
it was funny.
She thinks
Hey,
I'm.
was that not funny?
What'd you do?
She thinks it's funny that I'm gonna write you a detention. That's what she thinks
She
is
just said
funny.
kinda, he said he was ahead, and I said he was ahead.
On this one, I'm not sure what you gotta fill in on this. If there's nothing to fill in, we're gonna add some stuff to it. These are all things that you should look for when you are out of given information. So things that you should be able to come up with from everything that we've learned all year long. Very, very important. We're gonna add to this list as we go throughout this chapter.
What are the lines?
So when you get to, something and you've used up all the given information, these are things you should think about. The first one, vertical angles. When you have vertical angles, you might want to draw this picture on there. Somebody help Kellen out and tell him why that line's on there now.
What is it?
What do we know about those two angles right there that I just pointed at? They're congruent. So if you have something in a picture and it looks that way, it might be something that looks like this. We just had one of these a second ago. What do I know about those two angles? Congruent. Even though they don't tell us, we know they're vertical angles and they have to be congruent to each other. Reflexive property. What are you going to think of every time for reflexive? Anything equals itself. I'm going to draw just one little picture here for reflexive property. You could have something that looks like this. What do we know about that middle segment in those two triangles? Anything equals itself. Parallel lines. So if in the given information they tell you two things are parallel, what did I tell you last time that you should think of right away?
Interior.
Alternate interior angles. How are you going to tell if they're alternate interior angles?
Z.
Z. So if I drew a picture and maybe it looks something like this, add this. What's those two angles that I'm tracing right there? Alternate interior angles. If these lines are parallel, those are alternate interior angles, and what do you know about them? They have to be congruent.
And if you switch it a little bit, the rotation.
Yeah, because none of us ever, we never said that before, did we? That it made a Z or an N?
No.
We never said that.
I'll just answer the
So
question.
about vertical angles, for example, if a isosceles is like a vertical to like a scaling triangle, would it still be considered a vertical angle?
Yeah, so even if the two triangles, so if it looked like this, let's see, how could I draw
That looks goofy on.
I drew it wrong. Even if it looked like that,
They're still vertical.
these are still vertical angles, so they're still gonna be congruent. But are the two triangles congruent?
No.
No.
Similar triangle.
They may be similar. And we'll get to whether they're similar or not as we go. Next one, if you have two, in a picture, if you have something like this and one of the triangles has a right angle and the other one has a right angle, what do you know about those two right angles? They're always congruent. So, might want to make sure that you know that it's something that's got to be in your two-column proof. If you have a right angle in one, right angle in the other one, you're going to say, hey, this is a right angle, this is a right angle. then another step you're gonna have to say is that they're congruent to each other because all right angles are congruent. So you can't just say, I can't just tell Ethan N up here that, hey, that's a right angle, and that's a right angle. I also gotta tell him that they're both right angles, so we know that they have to be congruent to each other. Midpoint. What's a midpoint do to a segment?
What's the segment into two parts?
So you might want to draw that little picture. That's for a midpoint. Could be a bisector also. For a bisector, I'm actually going to deal with angles. You could bisect a segment. I'm going to bisect an angle. What do you know about an angle bisector? What's it do?
Splits it into two.
Two equal parts. So you could draw that. And if I could draw my marks there, that's terrible. You could have a segment bisector, you could have an angle bisector, you can have a midpoint of a segment. Can you have the midpoint of an angle?
Yeah.
No. Depends on if the arc is visible, right?
Wait.
No, you
A
can't.
midpoint.
If I draw an angle, if I have this angle and I say, draw the midpoint for that angle, does that make any
What?
sense
No.
whatsoever?
What about the arc though?
So if you drew a point in here, is that the midpoint of the angle?
No.
No.
That doesn't make any sense whatsoever, so you can't have the midpoint of an angle. It's just like bisecting a line, you can't bisect a line. Segment addition postulate, gotta be able to use segment addition postulate, we've been doing it all year long, I think it was like the second day of school that we did it.
That plus that equals what?
This is segment N, T, and that's an H. What do I know about these two segments?
Them together equals the full.
Those two add together equal NH, the whole thing. Segment addition postulate. Now where that's gonna come in handy for this stuff is if they give you triangles and maybe those triangles look something like this. Where they overlap is this bottom segment and this triangle the exact same as the bottom segment in the other triangle? No, but if we add this middle part to this and to this, and we know that these two are the same, using segment addition postulate, then we can say that whole thing is equal to that whole thing.
Could you have a midpoint of an arc? Or no?
Yeah, but not for an angle.
Okay.
So if I have an angle and I put this arc in there, that's just a marking to show that that
Yeah.
arc is the same, or that angle is the same as some other angle.
Right.
So we can't really have a midpoint of that. Now, if we're on a circle, and we'll get to this, and on that circle we have an arc, it's that distance from there to there on that circle, then we could have a midpoint of it right in the middle and split it up into two equal arcs.
Okay.
But we haven't got to circle yet. Cross section of a 3D shape. Fill in what you need to fill in on this. What's your,
Window.
oh, when it was my birthday. Just remind yourself each time, remind yourself. It's just a reminder that, hey, even though Ebersole's back's turned and I'm doing something stupid, he probably still knows it.
Huh?
He was doing something dumb and thought I didn't know that he was doing something dumb.
Come on.
And so when I turn around,
I think
he's
my
like,
hair is growing back to the
I'm not doing anything, I'm just stretching. And I pull him back.
My body is injured.
My body's injured.
I'm gonna go get my phone, and I'm gonna prop it right here, and then we'll have this same discussion, all right?
Yes, sir.
An intersection of a solid and a plane. Remember a plane? Just a if I take this book right here, that's a plane, right? It's got a length, got a width, sorta, because planes are supposed to do what?
Go on.
Go on forever, in all directions. Now, it doesn't have a what?
It,
Doesn't have a surface?
Doesn't have a thickness, all right?
thick, what?
All right, so it's got two dimensions. It goes this way
Yeah.
forever, that way forever,
But it doesn't
It
have.
doesn't go up forever.
but no thickness. All right. Now, paper does have thickness. This is why a plane is a undefined term in geometry, right? Because can I really show you a plane?
No.
No, because it's not supposed to have any thickness, so that's sort of impossible for me to show you. Okay?
It's like those,
With-
you know those like scanners, you know, like on whenever they're doing in like
Next
Avatar, you know what I'm talking about, where they're like scanning their body?
So,
Like a med scan. and-
Yeah.
so on this, what this does,
I know what you're talking about, right?
this plane, if I take this plane and what we're talking about here, and I chop the plane through my three-dimensional figure,
Okay.
we want to know what that little cross section would look like. And sort of what Kellen is talking about, if you go in to the doctor and you do like an MRI,
Yeah.
and you got to set in that machine and it goes over top of you and it comes back and it goes over top of you and it comes back and so on and so on. What it's doing, it's taking your body and it's cutting off cross sections of your body. All right? And then sort of piecing them all together so that the doctor can see what's going on inside.
Okay.
So what we're doing here is we're going to slice out a piece of each of these. And you got to know what shape is represented from that slice. So if I took this cylinder and I sliced it across through there and I took out that piece that I sliced out, what shape would I have in my hand?
Circle.
A circle.
Oh, okay.
Now, don't say still a circle because
It's a cylinder.
this is a cylinder. That's a three-dimensional shape. When I slice that piece out, it's not a three-dimensional shape anymore. It's just a two-dimensional shape. All right? So if we slice it that way, we would have a circle.
Ah, I see.
What would
If we sliced it this way, what would that slice look like?
a rectangle?
Alright.
It would be a rectangle. So you need to know that. All right?
I get it.
Okay.
I get it.
Now, the EOC test might do something stupid like this to you. What if you sliced it across corners?
No, would it still be a
It
rectangle?
would be a rectangle. Wait.
It'd
be an
ellipse.
No, it would be a.
Would
Would it be an ellipse?
It would be, yeah, it would be a rectangle.
Rhombus.
It would be a trapezoid.
Kite.
It makes sense.
Would it still be a cylinder?
I
don't know.
Would it,
Oval.
Would it be an ellipse?
So if we had this,
But it has.
and you sliced it from corner down to corner, what do you think you're gonna have?
Oval.
An ellipse.
And
That's not a shape.
Circle.
An
It's not
ellipse.
a shape.
I'm the best.
Alright? It would
I
look
said that
sort of
too.
like a circle, except
It's just a long.
it would be elongated.
I really thought it was a trapezoid.
Alright? Let's look at the next one.
Stared at it. Let's go this time.
On the next one, what if I cut it this way?
Square.
Square?
Yeah.
Yes.
Alright? What if I cut it across this way?
Rectangle.
Rectangle. Now a little harder one. What if I took it and I sliced it down through like this? Corner to
Rectangle.
corner?
Triangle.
It would be a
Rectangle.
rectangle.
It'd be
It's gonna end up being a rectangle.
Oh, we should draw that. That would be really smart.
Alright.
to draw. Thank you, Mr.
How about on this triangular prism? Remember this is, we talked about this? This is a triangular prism. How about if I sliced it this way?
Triangle.
Be a triangle? What if I sliced it across this way?
Rectangle?
End up being a rectangle?
Yeah.
Alright?
Yeah.
Now, let's see if I can erase this. Let's see if we can figure out. If I went from like this corner down to that side that way, what would it
It's
end
a
up being?
Triangle?
It'd end up being like a triangle. If you
Okay.
went from cross through that.
Corner to corner.
That's one. You drew the answer for us.
So that's a cross section. You gotta be able to take whatever shape. So what if I took this shape? Let's see, let's count these up. 1, 2, 3, 4,
It's an
5,
octagon.
6, 7. It's got 8. What kind of shape is that?
Octagon.
Octagon. What if I cut it, if I took this and I cut it right down through here, what shape would I end up with?
Octagon.
An octagon, an 8-sided figure.
Yeah.
What if I cut it across through here like this?
Be a
Rectangle. Traps.
Which one is it?
I think
Rectangle.
rectangle.
It's a rectangle.
Oh.
It'd end up being a rectangle,
Oh.
alright? What if I went from this edge down to this bottom edge? What would I end up with?
It'd be half of the 8, so it'd be, would it?
A four, like a square.
A trapezoid?
It sort of end up looking sort of like a trapezoid or something. And that's something that they probably won't ask you something like that because that's getting a little more than.
How do I get a trapezoid?
It's not. It's like two trapezoids. It would almost look.
Yeah, but what 3D object do
It-
I need to get a trapezoid?
It would almost look something like. I can't draw it very well.
Like a hexagon?
It would look something like that. All right.
What 3D
That looks
shape?
like a coffin.
Now, if I cut that in half, this side's a trapezoid, that side's a trapezoid.
Yeah.
It's a hexagon
Flat.
flattened out.
What 3D shape do I need to get a trapezoid?
What do you want to try?
Yeah, it's octagon.
What's your deal with?
Find this on your notes.
It's the
We're
one
gonna do
that
these
didn't
two
say
examples
trapezoid.
together. Then you should have a little bit of time to work on your assignment.
I say we just do our homework as an example.
That's
We can
what
do
he's
that.
trying to
We can do
say.
it together. We're gonna do these examples first. but-
Oh wait, yeah. it's
On
my
this.
notes.
Might not get this done. What's the first thing they tell us?
AD is parallel to AC.
So go over there and mark that on your picture. Do we need to separate off these two triangles? Can everybody see the two triangles without separating them?
Yeah.
Alright, so those two are parallel. Before I go any farther, before I look at any more given information,
Vertical angle.
what did we say if you have parallel lines, what should you look for? Keep that thought.
Alternate interior.
Alternate interior angles. So if I trace this, I trace this,
What's the transversal?
we could use that as our transversal. Is that alright? Or do we want to use something else? That's fine? Now, could we have used this as our transversal, DC?
Yeah.
Yeah, we could have. Let's just stick with one now, because we don't want to confuse ourselves. What do we know about those two angles? They are congruent, because they're alternate interior angles, right?
Yeah.
So that's a pair of angles. Is that enough to say the two triangles are congruent?
No.
No. Now, what I should have looked at, and I did look at it, Luke, but what I should have mentioned before I even looked at the given, is what information do you see?
Vertical angle.
Vertical angles. Does everybody see those vertical angles?
Yeah.
What do we know about them?
They're congruent.
They're congruent. They didn't even have to tell us that, so we know that. So that's another pair of angles. Are we using angle, side angle, or angle, angle, side? Do we know yet?
No.
Next piece of given information. What's the next piece of given information tell us?
BD is congruent to BC.
Where's segment BD at?
It's DB.
DB, where's it at?
The middle
The middle
line, half
line.
of it right there.
Where?
And go
Left.
over left.
Left.
The
That
left?
whole, that whole segment's.
Alright, so that segment's congruent to what? This one.
How do you, so do you know that?
How did we know that?
It's the given.
That was
Let's
given
get-
to us, wasn't it?
Yeah.
So that's a pair of sides. Now here's where you gotta be careful. Does that S go between those two or after those two? Is it between or after? Look at your picture. Is it between the two angles or is it not between the two angles?
Not two angles. No.
It's not
No.
between.
It's angle
No,
side.
it's angle side.
Angle.
So look at here, to be the included side for those two angles, which side would it have had to been?
AB.
Segment AB. So do we know AB?
No.
So is it gonna be angle, side, angle?
No.
No, it's gonna be angle, angle, side. So when we get over here to do our two column proof, we know that that's the one that we're using to prove the two triangles are congruent. What's our first statement gonna be?
Segment AD is relative to BC.
Oops.
I was given.
BC, that was given. Please, 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 I've been telling you this all the time. As we've been doing these two column proofs, do we just write all the given?
No.
No. If this tells us that those two are parallel, what's the next thing we should look for? alternate interior angles. We want to go in some kind of logical order so that we don't have the people saying, I'm confused. Logical order. Name the two alternate interior angles for me.
Angle A, angle E.
Is it alright to name that with just one letter?
Yeah.
Angle A is congruent to what angle?
Angle E.
And I don't mind if you name those with one letter. Next pair of angles that we name, you can't name with one letter, but those are alright. How do we know that angle A was congruent to angle E?
If parallel, alternate interior angles.
So if parallel lines, this again might be one that we want to write and put over there on the board. If two lines are parallel, then what do we know?
All interior.
Alternate interior angles are what?
Congruent.
Congruent. Might want to circle that or something. We're going to use it a lot.
I'm confused. Why did you not just use the given, the second given?
He just said because we wanna go in some sort of order.
And he all right. You better be kidding, Branson, because I'm getting ready to throw something. Oh, I swear to you. Today will be my last day teaching of my career. If
Now you know how famous it is. This is how you run this play.
I don't think it's.
This is a pair of angles, so we put a little A out there next to it. Is that enough?
No.
Where are we going to go to next?
The given.
Next given, if that's where you want to go. So what is it? BD is congruent to segment BC. How do we know that?
Good.
Given to us. That was a pair of sides, so I'm going to put a little S out there. Is that enough? Now what?
B and the midpoint of the.
Did we do the vertical angle?
Now we do the vertical angles. Now you got to be careful when you're doing the vertical angles.
A, B, D is
Jacob said angle ABD. How come he didn't name it with just one letter?
Because we already did that.
because we can.
Can you name that with one letter?
No.
No, if I just say angle B, do you know which angle I'm talking about?
No.
No, so you have to name it with three. And you gotta be able to pick out, when can I name the angle with one letter, when can I name it with three? What's the other angle?
CC.
CBE. How'd you know that those two angles were congruent? Another one that we're gonna use a lot. It's already over there, but
F2.
triangles were they?
Vertical.
So vertical
Angles are congruent.
angles are congruent. If you don't know that one by now, then we're
You tricked
in
me.
big trouble.
You made me look up there even though I knew it.
Vertical angles are congruent. What do I put out here beside the 4?
A.
An A. Is that enough to say that the two triangles are congruent?
Yes.
Yeah, now you gotta be careful here. So I'm gonna do number 5. We have enough to say the two triangles are congruent. Is it gonna be by angle side angle?
No.
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 Just because that's the order it's in here, does that mean that's the order it's in the picture?
No.
So make sure you don't get the two confused. What is our reason out here?
Angle, side.
Angle, angle, side. And then the triangles, they've already named for you, so we don't have to match them up ourselves. We just have to go over the back up there and recopy it down. Triangle ABD is congruent to triangle EBC.
What would you get?
Notice, we're using some of the same reasons over and over and over again.
Yeah.
So that's why these should be a whole lot easier. You should be able to do them every single time. Shouldn't be all that difficult. What was your question, Branson?
What would you get if you cut a regular tetrahedron? Like with the plane.
Tetrahedron?
A regular tetrahedron.
What is that?
Maybe this is why he doesn't know what we're talking about. He's looking at regular tetrahedron.
What's a regular tetrahedron? Read what it says. I can't answer that question because of what the way you're asking it. So what's it say?
A pyramid. I'll just say
Yeah.
pyramid then.
All right, so pyramid, different things.
Could be.
Oh wait, a regular tetrahedron has a triangle face.
Does a regular tetrahedron have to have triangles?
No.
No, it has a triangle face.
Isn't all those angles and sides
Hey,
congruent?
can I go to the bathroom?
I don't even know what that is.
All
Well, I
This is
can't
this
read
is a
that.
regular tetrahedron?
Yeah, the regular.
What is a
Yeah,
regular?
yeah.
Remember, a regular tetrahedron just has all the faces that are the same. Up there, they show a regular tetrahedron and all the faces are what shape? Triangles. This is a regular tetrahedron. It could be a soccer ball is a regular tetrahedron because all the faces are pentagons, right? Or hexagons, one of the two, I can't remember. Pentagons.
Hannah, what is it?
Yeah, Hannah, come on up.
You don't ever look at the soccer ball?
Isn't it a hexagon?
Hannah, you never be
think it's
looking
a
at the ball like, man.
Yeah, it's a hexagon.
What sides are
So what would you get if you cut a pyramid?
So if
I
you cut, if you cut a pyramid,
That's what I was trying to figure out.
A triangle, right? Just in
That-
half.
I'm pretty sure it's a
if
triangle.
I took this pyramid and I took a cross section of the pyramid, if I cut it this way, what would I get?
A square.
A square.
Square, yeah.
Because the base is a square, right?
Mm-hmm.
Yes.
If the base was a rectangle, then I would get a
Rectangle.
rectangle. If the base was a hexagon, what would I get? I'd get a hexagon. What if I cut it this way?
Triangle.
You get a
Yeah, triangle.
triangle.
what the face is?
Not a cone. It'd be a circle and a triangle, right?
If you cut it sideways, you would get a circle. Cut up and down, you'd get a triangle.
Oh.
Next one. You're probably right. That's probably why.
Because he just has to random, but.
What do you do with
Yeah,
it?
he
You
just-
just
I don't know, that one was kinda interesting though, I'm glad he asked it.
Still though.
He just tries to be silly and he's paying attention most of the time. He just likes to be a knucklehead and give me a headache.
Yeah, for real.
Me?
Yes.
He's supposed to be in your class.
He said
Who's? Me?
Yeah, you.
On this one, how many triangles in this picture?
Two.
Two. Two triangles. What's the first piece of given information tell us?
Segment HF is congruent to, or, parallel to segment GK.
Mark that in your picture. As soon as you see that, what should you look for?
alternate interior angles.
Alternate interior angles. Now, you gotta be careful here. Do I wanna use this as my transversal?
No.
It intersects them both. That doesn't give me the Z, does it?
No.
What do I wanna use as my transversal? What segment?
Segment HG.
HG. So we got that. So name the two angles for me that are alternate interior angles. Can we name an angle H this time?
KHG.
KHG, does everybody agree with that?
No, wait, did I do that backward? Oh, it's alternate.
KGH, that's this angle. FHG, that's this angle. So that's one pair of angles. Is that enough to say the two triangles are congruent? No, what else?
Angle F, angle here, right.
Angle F's a right angle, so I'm gonna mark that as a right angle. Angle K is a right angle, so I'm gonna mark that as a right angle. Put that in your picture.
And then
Is that enough to, what are we gonna do once we know that those are both right angles? They gotta be congruent to each other. Somewhere in our two-column proof, we got to say, hey, that's a right angle, that's a right angle. Then we also gotta tell whoever's looking at it next, that means they are congruent to each other, because all right angles are congruent. So that's another pair of angles. Is that enough to say the two triangles are congruent? But that's all the given information.
yeah,
But the middle line's the same.
anything
Segment
HG,
HG is congruent to segment HG because anything equals itself. Now that's a pair of sides in the two triangles. Does that side go in between the two angles or on the outside of the two angles?
In between.
Outside.
Angle,
The side
side.
is in between.
If it helps you, listen, if it helps you, then this is what you need to do. You need to separate off. I know this angle has one mark in it, correct? Does everybody agree with that, with that top
Yeah.
triangle? This one had that with the two marks, and then we marked that side. Is it between the two angles or outside the two angles?
Outside.
Outside the two angles. So are we using angle side angle or angle angle side?
Angle side.
Angle side again. Now, this doesn't have anything to do with the problem. We could have left out one of those steps somewhere in there, but we've already figured out that that's the way we're going to do it and that's the way we're going to do it. We could have left it out, and if I know that these two angles are congruent to these two angles, what do I know about this third pair of angles? They have to be congruent. Now could I have used angle, side, angle?
Yes.
So we could have done it that way, but that's not the way we went through it, so that's not the way we're gonna do it. What's my first statement gonna be?
Segment AJ is parallel to segment GK.
Before Branson thinks he's cute again, soon as we know that things are parallel, what are we gonna say next?
And
We're gonna do the what? Alternate interior angles. That was given to us. We don't wanna go to the next given, we wanna go to the, what that tells us. FHG, is that what you said?
Yeah.
And it's what other angle?
HGK.
Either way, as long as the G's in the middle, right? What's our reason for that? How do we know? If you have parallel lines, or if lines are parallel, then alternate interior angles are congruent. You gotta write that out that way, it's not that much to write. If you leave off the congruent part or any part of that, it's gonna be wrong. That's a pair of angles. Is that enough to say the two triangles are congruent?
Sir.
Where do we go to next? We need something before that. Angle F and angle K are what?
Congruent.
Right angle.
Or
Are
right angles.
We have to know that before we can say that all right angles are congruent. How do we know that they were right angles? It was given to us. Do I put an A out here beside that?
No.
No, because we didn't say that they were congruent yet, we just said they were right angles.
Number 4.
Now, what's number 4 gonna say?
Angle F and angle K are congruent.
Angle F is congruent to angle K. And how do we know that?
All right angles are congruent.
All right angles are congruent. And this is where a lot of you get yourself into trouble because you say, well, everybody knows that. No, if you're explaining something to somebody, right? Like when I explain something in here, do I say, yeah, 2 plus 3 and I just write it down and go over it and then
Everyone knows.
and then Kellen goes, everybody knows that, why do you gotta explain it? No, not everybody knows it. You got to explain things out. When you're explaining something, that's, my dishwasher at my house is broke.
Everybody knows.
And I'm watching a video yesterday of this guy explaining to me how to fix it. And he's using a voltmeter to test things out. And he's running through it going, yeah, this is 13.1, this is 12.2, this is 0, this is 7.8.
What's a voltmeter?
Exactly. But that's the way he did the video. And I said, you're an idiot.
You need to make a video.
Because you need to explain to people, and I know what a voltmeter is, and I know, you know, how he was doing it and everything. But the thing that he didn't tell me was, when I touch these two wires, what should the reading be? That's what I don't know.
Isn't the voltmeter like those two things and like you plug it, you push it into the metal and then it like sparks you?
No.
It tells you
A voltmeter
Right. Am I right?
is a little screen, and it tells you the reading of
Touch metal.
how the current runs through a wire. Alright?
What are the things that like,
Right. So you know,
Touch it.
so when you put it on there and read it, you don't want it to be like 300 volts, because then it'd kill your horse.
Yeah.
You want it to be enough to scare the crap out of them, but not to kill them. So if for some reason it gets kicked up and it's pushing 300 volts through
Your
there,
horse is gonna get stuck.
then you need to set it back down.
what are those things, like, the jump cable things? No, I plug in.
Jump cables.
Jumper cables?
Jump cables. Jump cables.
Oh,
Dummy.
like the ones you put on your car?
Yeah, those are called jump cables.
Oh.
So, back to this. But anyway, the guy on the video didn't explain to me what the readings should be. I have no idea what, you know, the readings, and as a matter of fact, I don't think he knew, because he got to one of them and he stuck them on there, and he pulled it off, and he stuck it on there again, and he pulled it off, and he stuck it on there again, and he goes, yeah, if you touch the outside left one and the outside right one, the reading's 0. And then he just went on. And to watch him,
I think it did it wrong.
to watch him stick it on there 3 times, like, oh, what's
Really?
going on here?
Really?
He didn't have any idea what he was doing, so I watched a different video to help me out.
Did
Oh, I thought this was a hypothetical.
You're an idiot. Just left it.
That's what I should have done.
Did you fix your dishwasher?
Not yet.
What's
So-
my new one?
Number 4. Number 4. What I put out here.
You
Angle
can-
F equals congruent.
That's an angle, right?
Yes.
Is that enough to say the 2 triangles are congruent?
Not yet, not quite.
We need something else.
Segment HG is equivalent to segment HG.
Segment HG is congruent to segment HG. Caitlin said we know that because anything equals itself.
Now that's enough.
What do I put out here?
F.
Now that's enough.
Yep.
Is that in the right order? Is it angle, angle, side? Is that the one we're using?
Yep.
Yeah, this time it is. So the triangles.
But it might not.
Let's do this. Forget that name's up there. Somebody name that top triangle for me. You're not allowed to name it GFH.
HFG.
HFG. So triangle HFG. Be careful. What's the H in this top triangle match up to in the other one?
G.
G. What's the F match up to?
K.
K.
Yeah.
And what's the G in this triangle match up to?
H.
H. What's our reason there?
AAS.
Angle, angle, side. Again, could we have used angle, side, angle? Yeah, we could have, depending on how we did the problem. But with the way we did it, that's what we used.
Thank you, Mr. Green.
I think we're fine.
You wanted to do this so we could do it.
We got handful man.
A little bit hate.
So that's what happens when we don't go over homework.
The assignment's on there. Make sure you do it. Thank you. On this problem, what you have to do, and I can't really show it on here, maybe I can. Let's do this. Front slide.
You started on the. Oh, yeah. Sorry.
We want to prove that triangle ABK, that's that triangle, and I'm going to separate it off over here. B up here, that's an A, that's a K, is congruent to triangle CBJ. CBJ. So that triangle right there. So it's sort of hard to see, and I'm not going to be able to keep this up here. We'll go through it, and then we'll drag and drop the stuff so you can fill in everything. That's a B, that's a C, and that's a J over here. So we're trying to prove those 2 triangles are congruent. Got to be careful because there's actually 1, 2, 3, 4, 5. There's like 6 triangles in this picture. You got to know which ones you're dealing with. First thing, segment AJ is congruent to segment KC. If I'm looking at these 2 triangles, segment AJ isn't in that triangle, and segment KC isn't in that triangle. AJ is this little part right here, and KC is this little part. But what we can do is, using the segment addition postulate, if I go from A to K, that's all the way across the bottom of this one, I'm adding on this part, JK, segment JK. And if I go going the other way, from C to J, I'm adding on that part to it. Well, if I know that this is the same as this, and I add the same thing to both of them, then I know from A to K is the same as from J to C. And what I used there was segment addition postulate, and that tells me that that segment's congruent to that segment. That's going to have to be in our proof somewhere. Next given says angle BJK. Angle J. Angle BJK is not actually in this triangle, but if I look up here, it goes BJK. It's that angle right there, which is this angle in that triangle. And it's congruent to angle BKJ. So it's that angle, which is this angle in that triangle. So we now have a pair of sides, we have a pair of angles. Then it says angle A, which is in this triangle, is congruent to angle C, which is in that triangle. That's another pair of angles. And we have to look at it, it goes angle, side, angle. So that's enough to say that the two triangles are congruent by angle, side, angle. And through that, I'm going to use segment addition postulate and substitution property, and then all the other information, the given information and stuff that we had there. But now I have to end the show, otherwise it won't let me drag and drop stuff. So this will give you this. First thing I'm going to drag and drop, segment AJ is congruent to segment KC, which is right here. That was given. Now that wasn't a pair of segments in our two triangles, but what it did tell us is that using the segment addition postulate, that segment AJ plus segment JK has to equal segment AK, and so on for the same thing here. And that's segment addition postulate as our reason. If I can grab it. Now once I have that, I didn't want those segments, I just wanted these two at the end here. And that's what I'm going to use next. Segment AK is congruent to segment CJ. And the way we got that was by substitution. Oops. I just took out one thing, stuck something else in its place. So now that's a pair of segments in our two triangles. Then I went to the next given here, which was these two angles are congruent to each other. That was given to us. That was a pair of angles in our two triangles, so now we have a pair of sides, a pair of angles. Then I went to the other two angles, angle A and angle C. It was congruent to angle C. That was also given to us. So clear down here in step 5, we're still using given information. Now I had a pair of angles, a pair of sides, and a pair of angles. That was enough information to say that the two triangles were congruent. And our reason, it wouldn't switch slides on me. Our reason was angle, side, angle. The assignment is on your notes. I'll pop it up here in a second also.